In this video, we'll give you a background on the rescue drill unit, the equipment purchased, successful rescue operations, and the acquisition of new equipment, as well as a simulated rescue. We would like to recognize all of the mining companies that contributed towards the rescue drill unit. On the 21st of January 1960, the Colebrook North mine collapsed. 435 miners perished in the event. It is still the single most tragic accident in the South African mining history. Following this disaster, the Chamber of Mines in 1962 agreed to the acquisition of a drill unit capable of extricating trapped persons from underground. Such a rescue operation would require drilling a probe hole to locate the trapped persons, as well as the drilling of a large diameter rescue hole into the workings through which to raise the trapped persons in a capsule using a mobile rescue winder. During the late 70s, the following equipment was purchased for the rescue of trapped coal miners: an Ingersoll Rand T5 drill, capable of drilling the 635mm rescue hole; an Ingersoll Rand T4 drill, capable of drilling 165mm probe holes, and an air booster compressor unit; a caravan housing a borehole camera, which will be lowered down the probe hole to locate trapped persons; and a mobile rescue winder with rescue capsules.
A rescue drilling rig has been sent from Witbank to Swaziland, where 26 miners have been trapped underground at the Emaswati coal mine since the fall of ground at 10 o'clock this morning.
During the life of the equipment, many holes had been drilled, but the success was a rescue operation at the Emaswati colliery in Swaziland. On the 8th of June 1991 at 10 o'clock in the morning, 26 mine workers were trapped by a fall of roof. Rescue teams were dispatched from Dundee, and the RDU was dispatched from CTC in Witbank. The RDU arrived at midnight, and drilling commenced at 3:15 a.m. At 11:45 a.m. on the 9th of June 1991, the rescue hole broke through into the workings, and at 1 p.m. all the drill rods had been removed.
Shortly afterwards, the proto team, which had been trained for this particular method of rescue, descended into the mine and reported that all was well.
At 2:46 p.m., the first trapped person was rescued.
Raised to surface in the capsule.
And at 4:45, the last person was safely back on the surface. The last rescue team member was raised at 8 minutes past 5 p.m. The RDU unit was used on a regular basis to drill rescue holes at many collieries. It was also used during emergencies such as this inundation of water at one colliery, where divers were lowered down the rescue hole. All of this equipment is more than 40 years old, and although it served its purpose, and it is still in fairly good condition, the replacement of spares, reliability, obsolete technology, and safety are reasons that it was decided to replace these units. During 2010, a steering committee and task team were established to consider all options for an upgrade of the old units, or to investigate the replacements of the units. After lots of deliberations, the steering committee recommended the purchase of a Schramm T130XD drill, capable of drilling a rescue hole together with sufficient compressors and an air booster pump. In addition, the committee further recommended replacing all the hammers, bits and drill rods, and to purchase lighter, more efficient RC rods and bits. The purchase of a Schramm T685WS drill for the drilling of the 165mm probe holes. Whilst busy with the upgrade, the committee also recommended the replacement of the mobile rescue winder, rescue capsule, probe hole camera, and the purchase of an additional gas chromatograph. The old mobile rescue winder was converted into the supply winder. Following these recommendations, the Collieries Committee approved funding of some 69 million rand for the replacement of the equipment. To demonstrate a rescue, the following animation aptly describes the procedure that will be applied to rescue trapped mine employees in the event of an entrapment due to a major collapse or fire in the underground workings. Firstly, Step 1 will be to locate the trapped miners by drilling a 165mm probe hole from the surface to a point underground where the mine employees are most likely trapped. Once complete, the sample tube of the gas chromatograph will be lowered down the probe hole to determine if any flammable gas is present. The borehole camera will then be lowered down the probe hole to locate the mine employees. Once located, the trapped employees will be provided with food, liquids, medication, as well as communications through the probe hole. Additional probe holes may be drilled. The supply mobile winder will be utilized for this function. The employees will be informed of the rescue procedure and that a rescue hole will be drilled through which they will be raised to the surface. They will also be informed of the holing position, as it may pose a danger when the drill breaks through into the working place. After the completion and inspection of the drilled rescue hole, the colliery's mobile rescue winder will be utilized to lower a rescuer in the rescue capsule to the trapped employees. They will then be raised, one at a time, to the surface. Following a major underground colliery fire in 2005, the Collieries Committee approved the acquisition of a mobile inertization system at a cost of 22 million rand. The unit consists of a mobile generator, a compressor trailer, as well as the Floxall trailer. This unit can be transported to any site and can produce 0.5 cubic meters of nitrogen per second or 1,800 cubic meters of nitrogen per hour at a pressure of 9 bar and a purity of 97%. The probe hole drill will be utilized to drill a hole into the fire area, whilst the rescue team members will install seals underground to contain the fire in the smallest possible area. On completion of the probe hole and the installation of the seals, the nitrogen will be pumped to the underground fire through the probe hole. During an underground emergency due to an explosion, underground fire or a roof collapse, the underground workers will, where possible, travel to a place of safety. Those trapped persons will notify their surface control, who in turn will commence the emergency procedures of notifying all concerned. Mines Rescue Services and the Colliery Training College, or CTC, will be notified and will immediately dispatch the SRAM T685WS drill to start the drilling of the 165mm probe hole. Once the hole has been drilled, Mines Rescue Services, or MRS, will lower a probe tube attached to a gas chromatograph to test for the presence of flammable gas, followed by the lowering of the borehole camera to locate the workers. Once the workers have been located, they'll be supplied with food, liquids and medical supplies by means of the mobile supply winder. Communications is vital at this stage, and the MRS personnel will establish communication through the probe hole. In the meantime, the CTC rescue drill personnel will deploy the SRAM T130XD drill to start the drilling of the 660mm rescue hole. This process can take time, as the penetration rate of the large rescue hole drill is slower than that of the probe hole drill. After completion of the 660mm rescue hole, the MRS mobile rescue winder will be deployed. The rescue capsule will be attached to the winder rope, and all the legally required inspections will be performed. The mobile winder will be moved into position, but before the rescue capsule can be lowered, the borehole camera will first be lowered down the rescue hole to inspect the condition of the hole. Special attention will be given to the transition point of the casing to the sandstone, as well as ingress of water and the presence of any cavities that may endanger the passage of the rescue capsule. The mobile rescue winder will then be positioned over the rescue hole. At this stage, a trained rescue team member will enter the capsule and be lowered down the hole. You will note the CCTV cameras inside the capsule as well as at the top and bottom of the capsule. This will assist the MRS-trained winding engine driver to continually monitor the operation. In addition, there are other safety mechanisms on the winder, including a dual communication system, slack and tightrope device over and under wind, and a second backup auxiliary motor in the event of a failure of the truck motor. The maximum speed of the winder will not exceed 0.5 meters per second. The capsule is fitted with 6 dolly wheels at opposing angles to assist with guiding down the hole, as well as negotiating rescue holes drilled at inclinations. The end load is 700 kilograms and the deployment beam is rated to handle some 1,500 kilograms. The winder is fully hydraulic and is the first of its kind in the world. Once the capsule has reached the bottom of the hole, depending on the seam height, the capsule may either just protrude out of the hole or, in the case of a high seam, will protrude almost totally. Ideally, the capsule should not exit the hole as the pullback will be more complicated. The rescuer will, at this stage, assist the person being rescued by ensuring that the person is safely inside the capsule. Only the rescuer will signal to the driver to start the ascent. As this process can be a frightening one, the driver will reassure the person in the capsule by continually talking to the person. Once safely on the surface, the person will be placed in the care of medical personnel.
What we would like to do now is to give you a live demonstration. We are sitting on the top of a coal mine. The coal seam is approximately 50 meters down. We have already lowered the borehole camera. You can see there it's 50 meters down the hole. There you can see the camera now reaching the working place. The camera is remotely controlled, and you can see the trapped persons. We will determine how many are there, what are their conditions, what do they require.
The South African coal mining industry now have the best and most modern rescue equipment in the world. To mark this auspicious occasion and to share our excitement with the launch of this equipment, we will demonstrate our capabilities with a simulated rescue.
You will now notice the first rescuer who will exit the capsule. He will then communicate to all the trapped persons, and by means of a triage system, they will decide who will be the first person to be rescued. There you can see the first person to be rescued will now enter the capsule. This person will be briefed on exactly what to do. This person will have an open line of communication at all times to the driver. Once in the capsule, the rescuer will then signal to the driver that they can now start to raise the first person to surface. Okay, here you can see the capsule on its way up. If I can now ask Mr. Msiza and Mr. Ace to accompany me, we will just cut the ribbon and then we will welcome the first person on surface. Thank you very much.
The South African mining industry has again proven itself to the rest of the world, where we have developed and provided state-of-the-art technology of this form of rescue equipment without any compromise to costs.